Hello students, in today's lecture we are going to solve NCERT exercise problem on thermal properties of matter. This is disclaimer. Learning objectives. By the end of this lecture you will able to solve questions on thermal properties of matter by applying concepts of temperature and heat, measurement of temperature and thermal expansion using proper reasoning and calculation. So in today's lecture we will cover NCERT exercise problems, thermal properties of matter. There are total 20 questions in this exercise. We are going to cover 8 questions, that is 10.1 to 10.5 and 10.7 to 10.9. Alright. So question is, the triple points of neon and carbon dioxide are 24.57 Kelvin and 216.55 Kelvin respectively. Express these temperatures on the Celsius and Fahrenheit scales. So in this question, you have to find out the temperature in Celsius scale and Fahrenheit scale. Alright. Let's solve this question. You have some time. Let's see the solution of this question. So, given terms, first the triple point of neon is Tk equal to 24.57 Kelvin. Triple point of carbon dioxide is Tk equal to 216.55 Kelvin. Alright. Now, here we have to calculate the given temperature triple points of neon and carbon dioxide in Celsius scale and Fahrenheit scale. Alright. So we know Kelvin and Celsius scales are related as Tc equal to Tk minus 273.15. Here Tc temperature in Celsius scale, Tk means temperature in Kelvin scale. So when we subtract 273.15 minus temperature in Kelvin scale, you will be get the temperature in Celsius scale. So this is the relation. So we know triple point of neon is 24.57 Kelvin. And triple point of neon on the Celsius scale, it will be given temperature 24.57 minus 273.15. Alright, because in the above expression, we already discussed the relation. So Tc equal to this one. Now after subtraction, it will be minus 248.58 degrees Celsius. Alright. Now, triple point of carbon dioxide in Celsius scale. So triple point of carbon dioxide is Tk equal to 216.55 Kelvin and triple point of carbon dioxide on the Celsius scale is 216.55 minus 273.15. All right, because we know the relation to convert Kelvin to Celsius, that is Tk minus 273.15. So after subtraction, the triple point of carbon dioxide on the Celsius scale is minus 56.60 degrees Celsius. All right. Now, Celsius and Fahrenheit scales are related as Tf is equal to 9/5 into Tc plus 32. So this is the relation, because here question asks about the triple point of neon and carbon dioxide on second scale, that is Fahrenheit scale. So triple point of neon is given, that is 24.57 Kelvin. So triple point of neon on the Fahrenheit scale is 9/5 into temperature in degrees Celsius, that is minus 248.58 plus 32. So when we solving this, you will be get minus 447.44 plus 32. So after addition, you will be get minus 415.44 degree Fahrenheit. All right. Now, triple point of carbon dioxide is Tk equal to 216.55 Kelvin, and triple point of carbon dioxide on Fahrenheit scale is Tf equal to 9/5 into minus 56.60 plus 32. As we know the relation, that is Tf equal to 9/5 into Tc plus 32. All right. So solving this expression, you will be get temperature in Fahrenheit, triple point of carbon dioxide on Fahrenheit scale, it will be minus 101.88 plus 32. So solving this, you will be get minus 69.88 degree Fahrenheit. All right. Two absolute scales A and B have triple points of water defined to be 200A and 350B. What is the relation between TA and TV? So here you have to find out the relation between TA and TV. All right. Please solve this question. You have some time. Let's see the solution of this question. So given triple point of water on absolute scale A, that is T1 equal to 200A. Triple point of water on absolute scale B is T2 equal to 350B. Triple point of water on Kelvin scale Tk equal to 273.15 Kelvin. All right. Now, since the triple point of water is a fixed point, so we can equate these values on different absolute scales to Kelvin scale. So hence triple point of water, that is 273.15 Kelvin on Kelvin scale, is equal to triple point of water, that is 200 A on absolute scale A. So when we equating this, it will be 200 A is equal to 273.15 Kelvin. It means A equal to 273.15 divided by 200 Kelvin. Alright. Now, similarly, triple point of water, that is 273.15 Kelvin on Kelvin scale, is equal to triple point of water, that is 350 B on absolute scale B. So when we equating this, you will be get 350 B is equal to 273.15 Kelvin. It means B equal to 273.15 divided by 350 Kelvin. Alright. Now let TA is triple point of water on the scale A, and TB the triple point of water on scale B. Alright. We have a two absolute scale, scale A and scale B. So triple point of water on scale A and B can be expressed as a TA into A and TB into B respectively. So triple point of water remains same on different scales. So we can say for the same physical state of water, both of the above expression must be equal. So we can write TAA is equal to TB into B. So putting the value of A and B. So we know A is equal to 273.15 divided by 200 Kelvin and B is equal to 273.15 divided by 350 Kelvin. So putting the value, you will get TA into 273.15 divided by 200 Kelvin is equal to TB into 273.15 divided by 350 Kelvin. Alright, now solving this expression, you will be get the relation, that is TA and between TA and TB. So TA divided by 200 is equal to TB divided by 350. So TA is equal to 200 into TB and divided by 350. Hence the relation between TA and TB is TA is equal to 4 by 7 times in TB. Alright. The electrical resistance in ohms of a certain thermometer varies with temperature according to the approximate law, and that is R equal to R naught into 1 plus alpha into T minus T naught. The resistance is 101.6 ohm at the triple point of water, 273.16 Kelvin and 165.5 ohm. At the normal melting point of lead, that is 600.5 Kelvin, what is the temperature when the resistance is 123.4 ohm? So here you have to find out the temperature. Alright, please solve this question. You have some time. Let's see the solution of this question. Now, given terms, that is R equal to R naught into 1 plus alpha into T minus T naught, where R naught and T naught are the initial resistance and temperature respectively. R and T are the final resistance and temperature respectively. Alpha is a constant known as temperature coefficient of resistance. At the triple point of water, T naught equal to 273.16 Kelvin. And resistance of lead is 101.6 ohm. At normal melting point of lead, T equal to 600.5 Kelvin. And resistance of lead R equal to 165.5 ohm. Alright. Now, substituting these values in the relation, you will be get 165.5 ohm is equal to 101.6 ohm into 1 plus alpha into 600.5 Kelvin minus 273.16 Kelvin. So solving this, you will be get 165.5 divided by 101.6 is equal to 1 plus alpha into 327.34 Kelvin. So it will be 1.629 is equal to 1 plus alpha into 327.34 Kelvin. So solving this, you will be get 1.629 minus 1 is equal to alpha into 327.34 Kelvin. Alright. Now solving this, the expression for alpha 0.629 is equal to alpha into 327.34 Kelvin. Solving this, you will be get 0.629 divided by 327.34 per Kelvin. So alpha is equal to 1.92 into 10 raised to power minus 3 per Kelvin. Alright. So let thermometer temperature be T prime when its resistance is R prime equal to 123.4 ohm. So using R prime equal to R naught into 1 plus alpha into T prime minus T naught. So putting the values, you will be get 123.4 ohm is equal to 101.6 ohm into 1 plus 1.92 into 10 raised to your minus 3 per Kelvin into T prime minus 273.16 Kelvin. Alright, and we already calculated the value of alpha. So solving this, you will be get 123.4 divided by 101.6 is equal to 1 plus 1.92 into 10 raised to power minus 3 per Kelvin into T prime minus 273.16 Kelvin. So solving this, you will be get 1.214 is equal to 1 plus 1.92 into 10 raised to power minus 3 per Kelvin into T prime minus 273.16 Kelvin. Further solving this, here T prime 1.214 minus 1 is equal to 1.92 into 10 raised to power minus 3 per Kelvin into T prime minus 273.16 Kelvin. So solving this, you will be get 0.214 is equal to 1.92 into 10 raised to power minus 3 per Kelvin into T prime minus 273.16 Kelvin. So solving this, you will be get 0.214 divided by 1.92 into 10 raised to the power minus 3 per Kelvin is equal to T prime minus 273.16 Kelvin. So further solving this, you will be get the value of T prime. Now solving for T prime, 111.46 Kelvin is equal to T prime minus 273.16 Kelvin. So T prime equal to 111.46 Kelvin plus 273.16 Kelvin. So T prime equal to 384.62 Kelvin. Alright. Answer the following. A. The triple point of water is a standard fixed point in modern thermometry. Why? What is wrong in taking the melting point of ice and the boiling point of water as standard fixed points, as was originally done in the Celsius scale? B is there were two fixed points in the original Celsius scale, and as mentioned above, which were assigned the number 0 degree Celsius and 100 degree Celsius respectively. On the absolute scale, one of the fixed point is the triple point of water, which one of the Kelvin absolute scale is assigned the number 273.16 Kelvin. What is the other fixed point on this Kelvin scale? Alright. And third one, the absolute temperature, that is temperature scale T, is related to the temperature Tc on the Celsius scale by Tc is equal to T minus 273.15. Why do we have 273.15 in this relation and not 273.16? And D1, D is what is the temperature of the triple point of water on the absolute scale whose unit interval size is equal to that of the Fahrenheit scale? So there are 4 questions and you have to find out the answers of these questions. Alright. So think about it. Let's see the solution of this question. So first, here question asked about the triple point of water is a standard fixed point in the modern thermometry. Why? Alright. And what is wrong in taking the melting point of ice and the boiling point of water as standard point fixed, as was originally done in Celsius scale? So we know triple point of water is always 273.16 Kelvin. So because triple point represents a unique combination of temperature and pressure. Alright. So at which the 3 phases of water, first solid phase, liquid phase and gaseous phase, coexist in stable equilibrium. So it does not change with change in pressure or any other external impurity. Melting point of ice and boiling point of water do not have a particular value because these points depends on change in pressure and temperature. Second, there were 2 fixed points in the original Celsius scale as mentioned above, which were assigned the number 0 degree Celsius and 100 degree Celsius respectively. On the absolute scale, on one of the fixed points is the triple point of water. Which one of the on the Kelvin absolute scale is assigned the number 273.16 Kelvin? What is the other fixed points on this scale? So other fixed point on the Kelvin absolute scale is absolute 0, or we can say 0 Kelvin. Third one, the absolute temperature Kelvin scale T is related to the temperature Tc on the Celsius scale by Tc is equal to T minus 273.15. Why do we have 273.15 in the relation and not 273.16? So we know 273.16 Kelvin is the triple point of water. It is not the melting point of ice. So temperature 0 degrees Celsius on the Celsius scale is the melting point of ice. Its corresponding value on the Kelvin scale is 273.15 Kelvin. Hence, the absolute temperature, that is Kelvin scale temperature, T, is related to the temperature Tc on Celsius scale. That is Tc is equal to T minus 273.15. Alright. Now, what is the temperature of the triple point of water on the absolute scale whose unit interval size is equal to of the Fahrenheit scale? So let here the temperature on Fahrenheit scale TF1 and temperature on the absolute scale TK1. And we know the relation between the Fahrenheit scale and absolute scale, that is TF minus 32 divided by 180 is equal to TK minus 273.15 divided by 100. Alright. Now, for the given set of TF and TK, TF1 minus 32 divided by 180 is equal to TK1 minus 273.15 divided by 100. Alright. Now, subtracting equation first from equation second, we get TF1 minus TF divided by 180 is equal to TK1 minus TK divided by 100. So solving this, you will be get change in Fahrenheit temperature is TF1 minus TF divided by 180 is equal to 1 by 100, because we know TK1 minus TK equal to 1 Kelvin. So TF1 minus TF is equal to 1 into 180 divided by 100. So solving this, you will be get an expression, and that is a change in Fahrenheit temperature. So we can write TF1 minus TF equal to 9 by 5. So we can say the above relation indicates the change of temperature in Kelvin scale is equal to 1 Kelvin corresponds to change of delta TF is equal to 9 by 5 degree Fahrenheit. Alright. Hence any Kelvin temperature change needs to be by multiplied by 9 by 5 to find equivalent Fahrenheit temperature change. So triple point of water is 273.16 Kelvin. Therefore, the triple point of water on the new scale is 273.16 into 9 by 5. So solving this, you will be get 491.69. All right. Two ideal gas thermometers A and B use oxygen and hydrogen respectively. The observations are made: temperature, pressure, thermometer A, and pressure thermometer B. So these are the observations. Question A is, what is the absolute temperature of normal melting point of sulfur as read by thermometers A and B? Second, what do you think is the reason behind the slight difference in answers of thermometers A and B? The thermometers are not faulty. Alright. What further procedure is needed in the experiment to reduce the discrepancy between the two readings? Please think about it and solve this question. You have some time. After that, we will provide the solution of this question. Let's see the solution of this question. So, A. Question asked about the readings. What is the absolute temperature of normal melting point of sulfur as the read by thermometers A and B? So the triple point of water, that is T equal to 273.16 Kelvin. Pressure in thermometer A at the triple point is Pa equal to 1.250 into 10 raised to the power 5 Pascal. All right. So this is the pressure. Let normal melting point of sulfur is T1. Pressure in thermometer A at this temperature P1 equal to 1.797 into 10 raised to the power 5 Pascal. All right. So according to Gay-Lussac's law, that is pressure is directly proportional to temperature. So we can say P by T equal to constant. So we can write Pa upon T is equal to P1 upon T1. So T1 will be P1T divided by Pa. All right. So solving for T1, just put the value. You will be get 1.797 into 10 raised to the power 5 Pascal into 273.16 Kelvin and divided by 1.250 into 10 raised to the power 5 Pascal. So after solving, you will be get 490.86 divided by 1.250. So T1 equal to 392.69 Kelvin. Therefore, absolute temperature of the normal melting point of sulfur as read by thermometer A is 392.69 Kelvin. All right. Pressure in thermometer B at triple point of water is PV equal to 0.20 into 10 raised to the power 5 Pascal. Temperature in thermometer B at normal melting point T1 of sulfur is P1 equal to 0.287 into 10 raised to the power 5 Pascal. According to Gay-Lussac's law, that is pressure is directly proportional to temperature. So we can say Pb upon T equal to P1 upon T1. So T1 equal to P1T divided by Pp. So solving for T1, so just put the value. You will get 0.287 into 10 raised to the power 5 Pascal into 273.16 Kelvin divided by 0.20 into 10 raised to the power 5 Pascal. Solving this, you will get 391.98 Kelvin. Therefore, the absolute temperature of normal melting point of sulfur as read by thermometer B is 391.98 Kelvin. All right. B. So oxygen and hydrogen gas present in thermometers A and B respectively are not perfect ideal gases. Hence, there is a slight difference between the readings of thermometers, thermometer A and thermometer B. To reduce the discrepancy between the two readings, the experimental should be carried under low pressure conditions. So at low pressure, these gases behaves as a perfect gases. Ideal gas to behaving the perfect pressure should be low. A large steel wheel is to be fitted on the shaft of the same material at 27 degrees Celsius. The outer diameter of the shaft is 8.70 centimeter and the diameter of the central hole in the wheel is 8.69 centimeter. The shaft is cooled using dry ice. At what temperature of the shaft does the wheel slip on the shaft? Assume coefficient of linear expansion of the steel to be constant over the required temperature range. And the value of steel value of alpha is equal to 1.20 into 10 raised to the power minus 5 per Kelvin. All right. Please solve this question and think about it. You have some time. Let's see the solution of this question. So given initial temperature T equal to 27 degrees Celsius, outer diameter of the steel shaft at T, D1 equal to 8.70 centimeter. Diameter of the central hole in the wheel at T, D2 equal to 8.69 centimeter. Alright. Coefficient of linear expansion alpha L equal to 1.20 into 10 raised to the power minus 5 per Kelvin. Given temperature T equal to 27 degrees Celsius can be written in Kelvin as T equal to 27.273.15 Kelvin, because we know the relation between the Kelvin scale and temperature scale, that is Tc plus 273.15. So you will be get the temperature in Kelvin scale. So T equal to 300.15 Kelvin. After the shaft is cooled using dry ice, let its temperature becomes T1. Alright. So will sleep on the shaft if temperature if change in diameter is delta D equal to D2 minus D1. So delta D equal to 8.69 minus 8.70 centimeter. Solving this, you will be get delta D equal to minus 0.01 centimeter. Alright. So fractional change in length is delta L by L is equal to alpha L into delta T. If the length is the diameter of the shaft, so delta D divided by D1 is equal to alpha L into delta T. So delta D equal to D1 into alpha L into T1 minus T. So solving this, substituting values in delta D, that is D1 into alpha 1 into T1 minus T. So just put the value, you will be get minus 0.01 centimeter is equal to 8.70 centimeter into 1.20 into 10 raised to the power minus 5 per Kelvin into T1 minus 300.15 Kelvin. Alright. So further solving this, you will be get minus 0.01 divided by 8.70 into 1.20 into 10 raised to the power minus 5 per Kelvin is equal to T1 minus 300.15 Kelvin. So solving this, you will be get minus 95.78 Kelvin is equal to T1 minus 300.15 Kelvin. It means T1 equal to 300.15 Kelvin minus 95.78 Kelvin. So after subtraction, you will be get a new value. So solving for T1. So T1 equal to 204.37 Kelvin. So in degrees Celsius, the relation is between Kelvin scale and Celsius scale, that is Tc equal to Tk minus 273.15. So T1 equal to minus 68.78 degrees Celsius, or we can say approximately minus 69 degrees Celsius. Therefore, the wheel will slip on the shaft when temperature of the shaft is minus 69 degrees Celsius. A hole is drilled in a copper sheet. The diameter of the hole is 4.24 centimeter at 27.0 degrees Celsius. What is the change in the diameter of the hole when the sheet is heated to 277 degrees Celsius? Coefficient of linear expansion of copper is 1.70 into 10 raised to the power minus 5 per Kelvin. Alright, please solve this question. You have some time. Let's see the solution of this question. So, given initial temperature T1 equal to 27.0 degrees Celsius, diameter of the hole at T1, D1 equal to 4.2724 centimeter. Final temperature T2 equal to 227 degrees Celsius. Coefficient of linear expansion of copper alpha L equal to 1.70 into 10 raised to the power minus 5 per Kelvin. All right. Now, using Tk equal to Tc plus 273.15, that is the relation between temperature degree scale, degree Celsius and Kelvin scale. So T1 equal to 27.0 plus 273.15 Kelvin. So T1 equal to 300.15 Kelvin. And T2 equal to 227.0 plus 273.15 Kelvin. So after addition, it will be 500.15 Kelvin. All right. So let diameter of the hole at T2 be D2. For coefficient of superficial expansion beta and change in temperature delta T, we have the relation. That is change in area divided by original area is equal to beta times delta T. So just put the value change in area delta A divided by original area A is equal to that is pi into d2 square divided by 4 minus pi into d1 square divided by 4 divided by pi d1 square divided by 4. All right. Change in area divided by original area. So delta A divided by A is equal to d2 square minus d1 square divided by d1 square. Now d2 square minus d1 square divided by d1 square is equal to beta into delta T. Using beta equal to 2 times of alpha L. So d2 square minus d1 square divided by d1 square is equal to 2 times alpha L into delta T. So it will be d2 square divided by d1 square minus 1 is equal to 2 alpha L t2 minus t1. So solving this, d2 for solving for d2 square divided by d1 square equal to 2 alpha L into t2 minus t1 plus 1. So d2 square equal to d1 square into 2 alpha L into t2 minus my t1 plus 1. So substituting values, d2 square equal to 4.24 centimeter square into 2 into 1.70 into 10 raised to the power minus 5 per Kelvin into 500.15 Kelvin minus 300.15 Kelvin plus 1. So solving this, d2 square equal to 4.24 centimeter square whole square into 2 into 1.70 into 10 raised to the power minus 5 into 200 plus 1. All right. Now solving for d2. So it will be d2 square equal to 4.24 centimeter whole square into 0.0068 plus 1. So solving this, you will get d2 square equal to 4.24 centimeter whole square 1.0068. So d2 square equal to 17.9776 into 1.0068 centimeter square. So when we adding, you will get d2 square equal to 18.1 centimeter square. It means d2 equal to under root 18.1 centimeter square. So d2 equal to 4.2544 centimeter. All right. Change in diameter, delta D equal to d2 minus d1. So we know the value of d2, that is 4.2544 centimeter minus 4.24 centimeter. So delta D equal to 0.0144 centimeter. All right. Hence diameter increases by 1.44 into 10 raised to the power minus 2 centimeter. A brass wire 1.8 meter long at 27 degrees Celsius is held taut with little tension between two rigid supports. If the wire is cooled to a temperature of minus 39 degrees Celsius, what is the tension developed in the wire if its diameter is 2.0 mm? Coefficient of linear expansion of brass 2.0 into 10 raised to the power minus 5 per Kelvin. Young's modulus of brass is equal to 0.91 into 10 raised to the power 11 Pascal. Let's see the solution. So initial temperature T1 equal to 27 degrees Celsius. Length of the brass wire at T1 that is L equal to 1.8 centimeter. Final temperature T2 equal to minus 39 degrees Celsius. And diameter of the wire D equal to 2.0 mm. Or in meter it will be 2 into 10 raised to the power minus 3 meter. So coefficient of linear expansion of brass 2.0 into 10 raised to the power minus 5 per Kelvin. And Young's modulus of brass Y equal to 0.91 into 10 raised to the power 11 Pascal. So solving this equation using these given terms. Now using Tk equal to Tc plus 273.15. So we can say T1 equal to 27 plus 273.15 Kelvin. So it will be 300.15 Kelvin. T2 equal to minus 39 plus 273.15 Kelvin. So T2 equal to 234.15 Kelvin. Let the tension develop in the wire be F. Alright. So Young's modulus is given by the relation Y equal to stress upon strain. So stress is force upon area and strain is change in length divided by length. So it will be FL divided by A into delta L. Change in length delta L equal to F into L divided by A into Y. So F is the tension developed in the wire. A is the area of cross section of the wire. L is the original length. And delta L is the change in length. Alright. Fractional change in length is given by the expression. That is delta L by L is equal to alpha L into delta T. So delta L equal to L into alpha L into T2 minus T1. So using the expression that is delta L is equal to F into L divided by A into Y, and second we get alpha L into T2 minus T1 is equal to FL divided by pi D square by 2 into Y. So solving this expression you will get the answer. So rearranging F is equal to T2 minus T1 pi into Y into D divided by 2 whole square. So substituting the values, F is equal to 2 into 10 raised to the power minus 5 per Kelvin into 234.15 Kelvin minus 300.15 into 3.14 into 0.91 into 10 raised to the power 11 Pascal into 2 into 10 raised to the power minus 3 meter divided by 2 whole square. When we solving this, you will get the expression for F. So solving for F, so F is minus 2 into 66 into 3.14 into 0.91 into 10 raised to the power minus 5 into 10 raised to the power 11 into 10 raised to the power minus 6. So further solving you will get minus 132 into 3.14 into 0.91. So F is approximately minus 337.18 Newton. So negative sign indicates that the tension is directed inward. Alright. Thank you for your attention.